All right. I hope you guys are doing all right. This is page 4 of the week 11 notes about indefinite integrals, aka antiderivatives. And on the right-hand side of this page, I've written some of the formulas, and these are the formulas we need for these particular problems. There's also a formula page for week 11 on Blackboard, as well as this notes packet. So for this first problem, we have the integral of x to the negative 1/2 power plus x to the 3/2 power dx. Both of those terms are x to a power, so they're both going to use this, which we call the reverse power rule. So because we're doing antiderivatives now, going backwards, when we take the integral or antiderivative of x to the n, we increase the power by 1, and then we need to pick up a 1 over that new power, n plus 1. So for each of these terms, part of doing it is going to be the n plus 1 expression. So up here, as scratch work, before we really dive into the problem, I want to do the n plus 1 work. Negative 1/2 plus 1 will be negative 1/2 plus 2 over 2. Negative 1 plus 2 is 1 over 2, 1/2. And the other n plus 1 that we'll have to do is for the other term, x to the 3/2, n is equal to 3/2. So we'll end up having to do 3/2 plus 1, n plus 1, which would be 3/2 plus, similarly, 2 over 2, which equals 5 over 2. All right, with those two guys done, let's start the problem now, which is the integral of x to the negative 1/2 dx plus the integral of x to the 3/2 dx. So we're using a property there that you can evaluate the integral of a sum by doing the sum of the integrals. And each of those is the reverse power rule. So for this first term, for example, we get 1 over n plus 1 is 1 over negative 1/2 plus 1 times x to the negative 1/2 plus 1. Plus, the second term is also x raised to a power, so it's 1 over n plus 1, which is 3/2 plus 1, x to 3/2 plus 1, and then a plus c. And even though there's two terms here, we don't need separate c's for the two terms. We just need 1 plus c for the general antiderivative or indefinite integral. And then we want to clean up these coefficients a little bit. So the n plus 1 part is what we did up top. So 1 over negative 1/2 plus 1 would be 1 over 1/2 is what it is. 1 over 1/2 x to the 1/2, based on what we did up above, plus 1 over 3/2 plus 1 is 5/2. 1 over 5/2 x to the 5/2 plus c. And that's equal to, well, 1 over 1/2 is keep, change, flip. So 1 over 1/2 would be 1 times 2 over 1, which would be 2, x to the 1/2 power, plus 2/5. Keep, change, flip again right here. 1 over 5/2 is 2/5, x to the 5/2 power, plus c. And that's the answer. And antiderivative indefinite integral problems are very easy to check, because if you take the derivative of what you think is the answer, you need to get back to the integrand here in order for it to check. I'll leave that to you to do, but it's worthwhile. So this is a formula. The integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. And that's because of the derivative formula. The derivative of the natural log the absolute value of x is 1 over x. And so this is going back. This is the going backwards formula. This antiderivative or indefinite integral formula is kind of the backwards version of this derivative formula. The indefinite integral of this side is equal to what's in parentheses, if you will, what's taking the derivative of on the left-hand side. This is a property of indefinite integrals, and it's just like the property we use all the time with derivatives, where you can take a constant out. So if we're doing the derivative of something like 2x to the third, we've been doing that for a long time, so it's just kind of automatic, 2x to the third. But there was a property that said we could take the constant coefficient 2 out in front and then do the derivative of x to the third. And this is a similar kind of property to that for indefinite integrals. So those guys, let's see, okay, we can do with this integral. So we have, first of all, this problem is different to the one that we just did, but one similarity is it's 2 terms added. So we can do them each separately. The integral of 5e to the x dx plus the integral of 2 over x dx. The 5 will come out. That's what I was just talking about, times the integral of e to the x dx. Now we're going to play a little game with this term here, the 2 over x, because up top here, right here, we do have a formula for the integral of 1 over x. We don't have 1 over x down here. We got 2 over x. But we can take out the 2, kind of like we took out the 5, and then put 1 over x in here. And what's that? What that is based on is 2, of course, it's 2 over 1. So we can multiply 2 times 1 over 1 times x is our 2 over x. But it's beneficial to us to take this 2 out and write it as the integral of 1 over x dx because of the formula in the box up here. And I think we're about good to go. On the right hand side is the integral of e to the x dx. So that's equal to e to the x. And that's because e to the x is this very unique function. E is a very special number where the derivative of the e to the x function is equal to e to the x. And so the backwards version of that is what's here. The integral of e to the x is also e to the x plus c. So here we go. We'll have 5 times the integral of e to the x dx, which is e to the x, plus 2 times the integral of 1 over x, which is a natural log of x, plus c. And for this last one, what we can do is kind of like what we did with the second term of number 6 up here. It's not over x, it's over x plus 5. But we do this formula on the right-hand side for the integral of 1 over x plus k. So we don't want that 7 there. We also have a negative, but we can take out a negative 7, write it outside of the integral sign, times the integral of 1 over x plus 5 dx. So that's the same as our integrand, because we can, to convince ourselves of that, kind of check it out, we can pop this negative 7 back across to the right of the integral sign, just on our heads. Just think this through with me. And then we can multiply negative 7 over 1 times what we have here, and that would be equivalent to this right here. Okay. And now it's set up to apply this formula, the right hand side, because it is the integral of 1 over x plus k, the integral 1 over x plus 5. So we get negative 7 times the natural log of x plus 5 plus c.